Now, let us look at another scheduling algorithm known as the shortest job first scheduling algorithm. In this particular scheduling algorithm, the job or the process with the shortest CPU burst time is scheduled before the others. Now, if you have more than one process with the same CPU burst time, then the standard FCFS scheduling is used. There are two variants of the shortest job first scheduling algorithm. The first is the no preemption variant, while the second one is the shortest job first with preemption. Now, in the SJF with no preemption, the process will continue to execute in the CPU until its CPU burst completes. In the second variant with preemption, it may be possible that the process which may get preempted when a new process arrives into the ready queue. We will see more on this later, but first we will start with the shortest job first variant with no preemption. So, let us take the same example that we have seen in the previous case. We had the 4 processes P 1 to P 4 and all of them are arriving at the instant 0, that is at instant 0 these 4 processes P 1 to P 4 get into the ready queue, and each of these processes have a different CPU burst time, that is 7, 4, 2 and 1 respectively. Now, in the first instant the CPU scheduler will look at the various burst times and find the one which is minimum. So, in this case we see that P 4 has the minimum CPU burst time. So, that is scheduled first. So, first the process P 4 gets scheduled until it completes. In this particular case it completes in one cycle. Then among the remaining 3 we see that P 3 has the lowest CPU burst time. So, process P 3 gets scheduled and completes till and executes till it completes its burst. Then P 2 gets scheduled because it has a burst time of 4, while P 1 has a higher burst time of 7, and finally P 1 gets to execute till completion. Now, the average wait time if we compute this is 2.75, while the average response time is also 2.75 as in the wait time case. Now, let us look at another example of shortest job first without preemption. So, we will take the same 4 processes P 1 to P 4 and each of these processes have the same burst time as before, that is 7, 4, 2 and 1 respectively. However, they arrive at different instants, that is the moment, the instant in which they enter into the ready queue would be different. So, P 1 enters at the 0th instant, P 2 in the 2nd instant, P 3 at the 4th instant and P 4 in the 7th instant. Now, this is a slight modification in the Gantt chart, where in addition to showing which process is executing in the CPU, it also shows the order in which processes arrive. It shows that P 1 arrives first, then P 2 in the 2nd instant, then P 3 and finally P 4 in the 7th instant. Now, when the scheduler begins to execute at this particular instant, the only process that has arrived at this particular point is P 1. Therefore, it schedules P 1 to execute. So, P 1 executes for its entire burst, that is of 7 cycles, and then at this particular cycle the scheduler enters again, or a scheduler executes again, and this time it has got 3 processes to choose from. All P 2, P 3 as well as P 4 have arrived in the ready queue, and out of them P 4 has the shortest burst time, therefore, it is chosen for execution. Therefore, P 4 executes in the CPU and then P 3 because P 3 has a shorter burst time than P 2, and finally, P 2 gets executed. So, if we compute the average wait time, we see that it is 3 cycles. So, the advantages of the shortest job first scheduling algorithm is that it is optimal, that it will always give you the minimum average waiting time, and as a result of this the average response time also decreases. The main disadvantages of the SJF scheduling algorithm is that it is not practical. Essentially, it is very difficult to predict what the burst time would be. So, another drawback of the SJF scheduling algorithm is that some jobs may get starved. Essentially, if you have a process which has an extremely long